So, welcome everybody to our second community call. If you missed it, we did one back in January for in a pre-recorded way that went up on YouTube. But this is our first live edition of these community calls, and we're expecting kind of a small group today, but that's exciting that we have company here, and happy to get your questions in at the end of the meeting here. This will be our first time doing this on Zoom, so bear with us as we figure out kind of the right production flow and handing things back and forth between people. There may be some little hiccups as we get our demos and things queued up here, but so far I'm feeling pretty good about this. We seem to have screen sharing figured out, so that's a good start. As with all of these calls, the central topic of this month's call is going to be the monthly release. That's the 370 release for February 1st, 2023. And there we're going to kind of highlight new features in the Moddable SDK and show some demos and just kind of talk about what's new and exciting on GitHub. But also mixed in, we'll have some news, other topics of interest to the community. And like I said, at the end of the call, a chance for people that called in to introduce themselves and ask questions of the team and just say hi. So it's going to be good. So first up, we are going to have Moddable CEO Peter Hottie give us a recap of his recent experiences representing the team at FOSDEM 2023 in Brussels. So Peter, take it away.
Cool, thanks. So I'm going to talk a little bit about this. FOSDEM happened this last weekend in Brussels. It is maybe the premier open source software show in the world. Really unusual conference. There's it's all run by volunteers, and there's no fee to attend. There's no fee to exhibit. There's pretty limited exhibition space, so we were actually really lucky to be selected to be able to show. We were there. If you've never seen the college, it's beautiful. It's old school Europe. The weather wasn't this nice, but that's actually the building we were in. And we were part of the IoT and hardware section. So really hardcore software developers who know way too much about embedded development. I would say mostly working on C, and that made conversations interesting. We'll get there. This is your team. It's me on the left, Patrick Soke in the middle, and Ralph Wetzel, who's one of our open source contributors. Ralph drove in from Germany to work the entire show and did a really fantastic job. This is the stand. You can see it's basically the show is in big hallways in the university, and we had a bunch of different microcontrollers connected to different sensors and different displays, showing all sorts of different uses of embedded JavaScript and things that people could do. This is upside down, but if it plays, it turns upside up. So this is an example of one of them, and we'll talk more about this one in a little bit. But people had a lot of fun just interacting with them, and they were really good places to start a conversation about embedded JavaScript. The key points we were there making and really landed well. One, much easier to code in JavaScript than doing things natively, and you pick up interoperability with the web ecosystem. Which is a really big deal with products that are supposed to be connected to the internet. Standardization played really well. Embedded developers understand that it's just a nightmare having to write your code to one silicon vendor's software stack. And then if you want to run on some other chip, you just start from scratch. And the security and reliability of JavaScript were a big deal. Something that we found was really an important point to make is that we were not at the show to take away anybody's C compiler. A lot of people thought we were saying, oh, you should just do everything in JavaScript. And they would explain why C was awesome. And we would agree with them and explain, of course, that you could interoperate between those two. And so JavaScript was just another tool. Ralph, our open source friend, was there to present a project we've been working on called Node-RED MCU Edition, which takes advantage of the fact that JavaScript is really standard to connect to the Node-RED ecosystem. And Ralph did a fantastic job. He was busy the whole time. His voice never gave out, and really had some in-depth conversations with people about how they could do home automation and device control using Node-RED. So very cool. And then Patrick, our French-speaking member of the team, was actually interviewed by French National Radio about open source and its benefits to businesses and software doing commercial software development. So, you know, if you're in France, maybe you'll hear that, but that seemed to go really well. So that was it. It was a really intense experience, really just immersed with incredibly passionate, incredibly capable and knowledgeable open source developers, and a lot of whom were learning about embedded JavaScript and excited at the prospect for the first time. There you go.
Excellent. Thank you, Peter, for presenting that. That's exciting stuff. I need to learn to pronounce that conference for future years. FOSS, free and open source, FOSDEM. I've got it now. Very cool. Well, if anybody has any questions about that, we'll get to those in the Q&A at the end. And we'll let everybody know next time we've got a show coming up so that you can come and see us stateside next time. Next up, we're going to jump straight into highlights of the February 2023 release. Like I said, this is release 3.7.0 of the Moddable SDK. And there's lots of good work in this release. A lot of kind of quiet, important, shoring up of details in the ECMA 419 network stack and things like that. But we'll get to those in a minute. Because we're doing this in a visual medium here, I'm going to start with the most visual new additions to the Moddable SDK. And that is a set of new ECMA 419 sensor drivers. First up on the list is the PZEM004T. This is a popular energy monitoring sensor. It is one of these deals that attaches to a power cord so that you can monitor the energy usage of an appliance or household product. And it monitors voltage, current, mainline frequency, power, energy usage over time, and the power factor of your home appliances. So here's a quick demo of the PZEM004T in action. If I can get this to work right. Let's see here. There you go. Hit play on that. And what you're looking at here, if we have a little luck, there you go, is a just little LED lamp plugged into a power cord that's been augmented with this sensor. And the sensor itself is plugged into a Moddable tube. So if we zoom in here on the Moddable 2, you can see the voltage, current usage, power, energy, frequency, and power factor. And as I toggle this light on and off, you can see that when the light is on, it's drawing about 7 watts. There's the little resistor there on the power supply cable that allows this thing to do its measuring. And when I turn the lamp back off, we go down to a little more than 1 watt, which actually is the power for the sensor in the Moddable 2 itself. It's plugged into the lamp. And then when I hit clear energy, that communicates with the sensor and tells it just to reset that rolling watt hours measurement that's displayed there on the device. So yeah, that's the PZEM004T. We have 2 new examples in the Moddable SDK for that. That visual example that you just saw there, built on top of the Pew user interface framework, and then also just a basic terminal console version of that spits out debugging information to XSBug. Second up on my list is the APDS 9960. That is right in front of me. I can show it to you. It's this little purple sensor right here. And that is the most recent in a long line of ambient light and proximity sensors from Broadcom. It's a device that's frequently used in smartphones and other applications where you need to constantly adjust a display in response to changing light conditions and to the user's proximity. So it can do things like ambient light level, proximity, color, temperature of the ambient light, that sort of thing, allowing you to futz with the display in response. And unlike the HC SR04 that I featured in last month's video, this proximity sensor is extremely short range. It's really made for detecting if a user's hand or face is right up next to the glass of the device. It's not a multiple meters thing like those ultrasonic sensors. And this new version of the sensor, the 9960, also adds a few extra little proximity diode sensors in there so that you can do some very rudimentary gesture detection using the sensor. So if I fire this up, now hopefully you're seeing me using this sensor. And up there in the top left is just console output from XSBug that I'm sure is hard to read. But the point of the story is just that you can see things, you can see interrupts firing and debug information going to XSBug as I change the ambient light levels there. So this is an interrupt driven example with an extra pin wired between the two to trigger a callback when an interrupt happens. Then this is proximity, again, interrupt based. So you only get callbacks from the sensor driver when there is a object being actively detected. And then the last one is the gesture detection. So there's a gesture right, a gesture left, a gesture up, and a gesture down, all being sensed by the little IR LED and IR receptors that are on the APDS 9960. That's that one. I like that guy. And then finally, in my list of ECMA 419 conformant sensor demos here, we have the AMG 88XX, popularly known as the grid eye sensor. And this is an 8x8 pixel thermal camera made by Panasonic that makes it easy to detect movement and when a person is nearby. So it's used for security applications. I've seen them used in kind of complicated home heating and cooling systems where you're looking for temperature of the wall versus temperature of the furniture and things like that. And you even see these things used in safety applications like fire detection. They're good at picking up very rapid changes in temperature of objects in the room. So Peter gave you a little preview of this earlier, but here is a demo of that sensor in action. So you can see over on the left on the Moddable 2, there is the 8x8 sensor values being visualized with brighter reds and oranges for hot temperatures and the cool blues and purples for colder temperatures. And there it goes. Very neat. Cool. So those are kind of the fun, nifty demos I have ready to go for this call. As you can tell, a lot of our public-facing focus these days is on improving and expanding our support for ECMA 419, that standard that we're very involved with. And those 3 new sensor drivers that we did there are not all that we did for ECMA 419 this month. There were also, if we dive into the release notes, many improvements to the 419 network stack and to existing sensor drivers. So we did a lot of work this month on LWIP, versions of TCP and UDP, the MQTT client, the HTTP client, fixes to our touch controllers, fixes to the pulse width and pulse count, implementations for 419, pressure and temperature sensors, changes to that distance sensor I was talking about. Lots of good work there, all up and down the stack. And in addition to bringing new features to the Moddable SDK, a lot of what we've been doing lately is continuing to expand and reinforce our support for microcontroller platforms. So an example of that this month is that we had a number of updates to our build system for the ESP32C3 in order to account for a bunch of changes that Espressif made in the ESP IDF for their RISC-V support. And that's something I just wanted to highlight very briefly because there's really a lot of exciting work going on in the RISC-V ecosystem right now. And we're excited to be providing cutting edge support for JavaScript there on that platform. So neat stuff happening there. Let's see, what else have I got? One other big chunk of work that went in this month was support for the ESP32's built-in Ethernet MAC. So this is, if you've never worked with this, there's an internal Ethernet component, a MAC, on every ESP32. And if you use it, it allows for significant savings on the bill of materials for products at the expense of kind of using up a number of the ESP32's I/O pins. And so we built out this support for the internal Mac. It was built to work with a number of different PHYs and the 8P8C jacks that go with it. Somewhere here, I had one to show you, but I'll just show you the video instead. That's okay. The PHY that we tested this with the most is the LAN 87XX, which is built into the WT32 ETH01 development board, which is a rather popular development kit for people out there trying to work with Ethernet on ESP32. And we set this all up so that you can use either Wi-Fi or Ethernet interchangeably with a runtime decision on which to use. And you do that by including both manifestnet.json and manifestnet ethernet.json. And that happens for you automatically on the WT32 ETH01 platform. So I'll show you one more quickie video here. So we keep things moving along here. That shows you that device right there. That is your WT32 ETH01 with an Ethernet cable plugged into it. And as you can see, it's a wee little bit finicky. You have to fly wire it out to a USB connector to get UART to serial to talk to the computer. And then you have to do this little dance where you connect and disconnect the DTR pin to GPIO 0 on the ESP32 every time you program it. But if you do that and you load up the correct target and you run, in this example, an HTTP example, if you provide at the command line or in your manifest Wi-Fi information, it'll use it and it'll connect to the Wi-Fi AP. And if you don't, it'll wait for an Ethernet link. And when you plug in the Ethernet cable, it's a little faster than I intended. When you plug in the Ethernet cable there, you can see that it connects to the internet over Ethernet, gets an IP address, and goes off and fetches the weather conditions in Menlo Park. So that's that example. Tell you what, I'm going to skip the next video because we're going a little long here. And that is okay. And I'll just tell you briefly that we also have added in some new improved Windows support this month with a tweaked build that brings our build times of the Moddable SDK tools and simulator builds more in line with Mac OS and Linux builds when using modern Windows hardware. So historically, a lot of our work on Windows has been done in virtual systems using Parallels or similar tools. And so we hadn't had much of a focus on parallelization in our Windows builds. We've gone through and done that, and now we have kind of very fast parallel calls to CL in our Windows tools and simulator builds, and also a multi-core, multi-nmake file processing at once build of the full Moddable SDK tools that gets a tools build down to about 20 seconds on my Ryzen 9 7950X based desktop here. So pretty handy if you do Windows tools builds as often as I do. With that, I'm just going to kick it back over to the release notes for a second. I don't want to belabor the point too much, but I just want to note that we have a lot of great work that's gone in here over the past month in terms of improving XS, finding and fixing issues that have come up through fuzz testing, partly done in conjunction with our friends at Agoric, fixing up different details in how XS works so that it is reliable and performant and works the same every time you run it. And then Peter has been doing a lot of work on developing new tests for networking modules in the past month. So this is stuff that applies across all of our different target platforms and that really ensures the reliability of our network stack every place that it's running. So it's important work that's happening there. And we've also had some additions to TypeScript this month. So lots of good things going on. So again, I don't want to belabor that. We'll take any questions on that in just a minute. But first, I want to pitch over to our brand new Moddable intern, Daniel Abdu. Daniel's been doing important work on a new project to support both the Moddable SDK and ECMA 419, which, as we keep saying, is the embedded JavaScript standard that Moddable helps to drive. So I'll toss this to Daniel, and then I'll sum up a little bit after Daniel's done. Go for it, Daniel.
Thanks, Andy. Yeah. Hi, everyone. I'm Daniel. So one of the things that I wanted to talk about was our one project I've been working on is essentially creating a list that allows us to sorry, a little nervous my first time. I'm going to start over. So at Moddable, we want users to be able to support a wide variety of projects. And we realized that most of the common feature requests that we get are for additional sensor support. But in building out new ECMA 419 conformant drivers for those sensors and anticipating the sensor needs of potential Moddable SDK developers who have not yet spoken up, it's a pretty high priority. So while no platform can really support every sensor, I've started making a list that I think best encompasses what users would most need or be interested in for their projects. And this extends even beyond what's supported by ECMA 419. But of course, we want the community's feedback on this as well. What it's initially started out as is essentially a list of the most popular and all the sales data that we can get from different purchasing sites for these types of sensors. So Amazon, SparkFun, things like that. And so we wanted to also reference similar projects as well to Moddable, like ESP Home and Tesmoda, and included some sensors from those projects as well. In doing this, we've realized a couple of main points about what sensors are out there and our support for them. There's a lot of sensors that we may have support for, but not exactly. So something like a radon sensor or ozone, we don't directly have support for it, but it's very similar to other sensors that we do support. So, we'd like some feedback also on how we should address adding support for these types of sensors that are similar, but not quite what we have already in place in the standard. Also, in electronics like digital potentiometers, which are very commonly used alongside other sensors, we don't directly support them, but we want to know if this is something that everybody would want, or if it would just more so be a nice to have as part of what we support. In addition, Andy already kind of touched on this, but we don't really have direct support for power monitoring, but we're starting to get on it. And a lot of sensors that we found as part of the research on popular sensors has been various power monitoring types of devices. So that's something we're working on, and would like some feedback also if that is the right direction that we're heading in. So any changes or additions that can be made to this list, I made a community post right before this call. So you guys can check out the list and let us know what changes we can make so that we can prioritize what's most important for the community.
Very cool. Sorry, we were chatting in the background. Very cool. So I'm very excited about this project, and I'm very excited about getting the community involved in this. As those of you who have kind of watched our release process and watched new drivers and driver examples come into the Moddable SDK know, we have a very structured process for building out sensor drivers that conform to the ECMA 419 specification. We're not just kind of individually winging it for different drivers here. We're building up a library of drivers with very interchangeable APIs that conform to ECMA 419 so that they'll be useful for people that want to be able to quickly change between different sensors, different hardware components in the same project and in the same product. And then also, as Daniel mentioned there, we're going to be using this process of identifying important sensors and the key needs of the community to expand out the ECMA 419 specification by defining new sensor classes. So every year there's a new edition of ECMA 419. One of our goals every year is to pick a handful of sensor types and blast through a bunch of different driver examples in that class so that we can abstract away the kind of common ground amongst those sensors and come up with the text that goes into the sensor class of the ECMA 419 specification. So very cool stuff. And thank you to Daniel for sharing that list. If you missed the link in the chat or you're watching this later, if you go to our GitHub repository for the Moddable SDK and into the GitHub discussions tab, you'll see that discussion right up at the top with that list. So speaking of ongoing community contributions, I next wanted to share a list of folks that had made contributions during the month of January. Here you go. This is our list of February 2023 release community contributors. And thank you so much to everybody involved and everybody that opened issues, got on Gitter, talked to us, open discussions, provided us feedback on Twitter. The list that I have here are just the folks that kind of made it into the release notes, but that's Agoric, who supported with fuzzing and test development, Raf Dev for support of metering in XST for OSS fuzz, Cineos for updates to sensor summary document, TVE for fixes to serial to access bug on Linux and typing contributions. You're on the call, I believe. Thank you. And a handful of bug reports and suggested fixes from Kitazaki, M. Shioji, and Ralph Wetzel. So thank you all for your contributions this month. And everybody out there in the community, keep it going. We really appreciate everything that you bring to the table for us. So with that, I wanted to kick it over to Q&A for a moment. If anybody has any questions, feel free to turn your camera on or your audio or just type in the chat. I saw that we had one here. Hang on. Is there a good example for a driver that has an interrupt handler written in C? Usually with interrupt handlers written in C, so Peter might have a different answer to this because he's worked on the touch controllers, which I think to some extent do that. In my case, I'm usually doing the interrupt handling in native code for the IO type. So a good example of that is the pulse width measurement IO that just went in recently for the ultrasonic range sensor. And that has on the IO type an interrupt handler that's implemented natively that then bubbles up a callback into the JavaScript stack that the sensor then handles at the JavaScript layer. But Peter, do you have any example of a sensor implementation that has callbacks that are implemented natively?
Sorry, scrambling for the unmute button. The sensors don't usually have an interrupt handler because they don't need to respond that quickly. You know, I mean, we can bounce from the interrupt to JavaScript in well under a millisecond, so it's fast enough. The IO examples you point to are pretty good. Looking at like how the digital GPIO is implemented is a pretty good example of that. You can definitely do it. I've been recently working on a display driver that needs to handle interrupts and respond very quickly. I mean, it basically comes down to knowing at that level, knowing the host operating system you're working on, like FreeRTOS or whatever. And then it's just a question of how to bounce back and forth to JavaScript outside of interrupt level, because you really can't safely call the VM from an interrupt. But happy to walk through some examples of that, like in a discussion post or something, if it's helpful.
Yeah, we'd be curious to see the driver that you're working on and if we can help there, because it's always an interesting compromise on how you structure these drivers when you care about like real-time precision on when data is arriving on these systems. But we have not yet come across anything that's impossible to do. It's just a matter of kind of how you structure the thing to catch those interrupts and capture the data at the source as it's coming in before you bubble it up into the VM. Other thoughts, questions? There was a suggestion earlier up in the chat about having uBlock's GPS support in our sensor libraries. Agreed, it's complicated, and we've taken a first pass at it. Both Mike and I have done a little bit of work on that for various projects, but I would love to get that into 419 land eventually. That's definitely on the list. Anyone else? Excellent. In that case, I'm going to go ahead and start wrapping this up. Thank you so much to everybody who dialed in today and said hi. For those who couldn't make it today and are watching this later on YouTube, please drop by our Gitter to chat, start a new discussion on our GitHub repository, or contact us on Twitter at Moddable Tech. And otherwise, we'll see everybody next month after the March release. We'll plan on doing this again first week of March. Thank you so much.